Okay, so our second section we're going to look at this week is 2.2. So it's solving inequalities, which is very similar to solving equations. The only difference is instead of an equal sign, can somebody tell me one of the symbols you might have in place of the equal sign? About Nicole? Oh, you might have a less than. What else could you have? Savannah? You might have a less than or equal to. Yeah?
You might have a greater than or equal to.
A greater than or equal to, or a greater than. So you're going to have one of those four symbols instead of an equation, or an equal sign. All right, how do we, someone remind me, how do you pronounce that? If you were going to read that off to me and just say what it says right there, what do you read?
A is less than B.
Yeah, A is less than B. Right, so you've got a spot on your notes. You've got a blank right there. You want to fill in what's in quotes. Now, it says below it what that means. So, especially with negatives, if you get stuck and you're like, I can't figure out, negative 10, negative 11, which one is less than the other? Well, I think of it like it's on a number line. All right? If I draw a number line, and I had 0, negative 1, 2, 3, 4, 5, negative 6, 7, 8, 9, 10. Some people see negative 10 and they're like, oh, 10, it's a bigger number, right? Not when it's negative, right? If it's negative, negative 5 is bigger. It's always the number that's, where'd it go? Okay. It's always the number that's to the right, the number that's closer to 0 when you're looking at the negatives. Okay, so numbers that are to the right are bigger than numbers that are to the left. Or you can say that numbers to the left are smaller than numbers to the right. How about this one? C, inequality symbol D. How would you read that one? Oh, Nathan?
C is greater than D.
Yeah, C is greater than D. So on the blank, right at the top, you want to write down what's in quotes. C is greater than D. Okay. What that means is if you've got a number that's bigger than another number, right? Like if I just use this number line again, is 5 bigger than 0? Yeah, 5 is bigger than 0. Look where 5 is. 5 is to the right of 0. So any number that's to the right of another number is bigger. So you go to the right, you get bigger. You go to the left, you get smaller. Okay, I think most people can do that pretty good with positives. I think sometimes with negatives, they get a little tripped up, but I know Mr. Roy explained it yesterday too. All right, so solving an inequality. Basically, that means to find the solution set. Now, yesterday, we had you guys just check like a single number to see if it's true. When we did the warm-up today, and we tried plugging in different numbers, we saw that there's a bunch of different numbers that might make an inequality true. Okay? It's not just a single number. Okay? That's what an equation is. You get one number that's the answer. With an inequality, you get a bunch of numbers that can be the answer. Okay? Usually it's like anything that's bigger than this number. So if I said like x is greater than 2 is the answer, that means you can pick anything you want greater than 2. 2.5, 3, 107, doesn't matter. Anything bigger than 2. So how many numbers are bigger than 2? Yeah? An infinite amount, exactly. So when we're solving inequalities, the solution set is huge. It's infinitely big. Okay, that's what we're saying. It's huge. It's infinitely big. All right. So where it says when solving an inequality, okay, the part that's underlined, we're trying to get the variable by itself. And generally, you want to do it the way we explained it yesterday. Letter, symbol, number. Okay, so you always want letter, one of these symbols, number. Why do we like the letter on the left side? What's the good thing about putting the letter on the left side?
Why is it important? What else are you going to have to do? You're not only going to have to solve, but what else are you going to have to do? We're doing these, right? But most of the time, besides solving it, you're also going to have to do what? You did it yesterday.
We did it in the warm-up.
You get a number line. Math? Graph, right?
So if you have to graph it, why is it important that you put the letter on the left side? What happens if you put the letter on the left side if you look at the inequality symbol? What does the inequality symbol tell you? Yeah?
What way the arrow goes.
Yeah, tells you which way you're going to end up shading on the number line. If you don't put the letter on the left side, the inequality symbol does not tell you that.
Then you have to remember that if you don't put the letter on the left-hand side, then the direction, if your letter's on the right, you got to know enough to say, okay, it's not in the right order. I have to draw my line opposite of the way the arrow's pointing. If you don't flip it, you have to remember that. If you don't, that's why I was saying it might be a good idea to flip it, because then you go in the exact same direction as the inequality is pointing.
I wrote 2 greater than or equal to's up here. I meant to put greater than for one of them, greater than or equal to for the other. But I think people do that. Okay, so let's. Right, so I already said this a couple times, but when you're solving an inequality, especially when all you're doing is adding or subtracting, it's just like solving an equation. There's nothing that's different. Nothing at all. The only thing that can be different, and that's what Mary said we'll look at tomorrow, is when you multiply and divide and negatives are involved. But that won't happen today. So let's try the first one. All right, so they want us to do 2 things. They want us to solve it, then they want us to graph it. Anyone think they can tell me the one step that I have to do to get x by itself? Ellie?
Subtract 8 from both sides.
Okay. So if I do that, what's negative 8 minus 8?
16. Wait, no. 1. Would it be 0?
No, it wouldn't be 0. If I did negative 8 minus 8, that would be negative 16.
Oh, so you have to. That's not.
Yeah.
Add 8 on both sides.
We want to add 8 on both sides. So the goal is to make sure we get that negative 8 to disappear, right? We're putting it on the other side, so you always want to do the opposite. If you see minus, you do plus. If you see plus, you do minus. So I get x is less than, and what's negative 8? Oh, I'm sorry, what's negative 11 plus 8? Yeah? Negative 3. Okay, the way I think of it, sometimes I think of it in terms of money. If you think of negative as like you're in debt, like if I owed someone $11, negative is I owe them money, and I paid them back 8, well, I still owe them more money. I'm still negative. I'm still negative 3. Okay, so there's our solution. Are we good?
No.
No, I'd give you half credit for that. What else you gotta do? Yeah.
Get a graph.
Yeah, you're gonna make a graph. So on the test, you'll already have a number line drawn for you.
Yeah, sometimes on the test, that type of question might be multiple choice, so you just have to pick the right graph. That's all.
Again, lots of ways to number your number line. You can go by 1s, you can go by 2s. I just went by 3s. Okay, as long as you're consistent. Don't do something like this. You can't say, oh, I'm going to go by 3s, and then all of a sudden I'm going to go by 1s, and then maybe I'll go back to 3s again. No, you just go by the same thing all the way through. Okay, So what do I have to decide first? First thing I have to decide. Yep.
I have to decide which way it's going.
Okay, I got to figure out which way it's going, but even before that, there's something I got to put first. Yep.
Open and close.
I got to decide if it's an open or closed circle. All right. How do I know if it's open or closed? Matt?
It'll be open if there's no line under the symbol.
Exactly. No line under the symbol, we do an open circle. And we always do it on the number that we see in the problem. Open circle. Now, is this problem set up the way we want it? Is it in the order that it should be? Yeah. So then this tells me, Ryan, what does that tell me since it's in the order that we want? Yeah, good. We're going to shade to the left. So we're just going to shade to the left. Now we're good. There's our answer. Any question on that one? All right, so I'll do one more with you guys, and then I'll have Mr. Roy jump in and take a look at some other stuff. All right, so solve and graph. B minus 2 is greater than or equal to minus 9. Okay, again, it's just going to be one step. We've done equations that are a lot harder than that, right? We've had distributive property, combined like terms. We don't have any of that in this problem. Not saying you'll never have any of that, but at least in this one you don't. Okay, anyone tell me my one step to get B by itself? Donovan?
Add 2 to both sides.
Yep, we're going to add 2. Add 2. Donovan, what's negative 2 plus 2?
0.
0, that's gone. So what's left on the left side?
B.
B. So I've got my B. Copy down my symbol. Okay, the symbol never changes. Okay, no matter what you do with adding and subtracting, you never have to flip that symbol. All right, for today. And then negative 9 plus 2. It's negative. Jacob, what's negative 9 plus 2? Right, think if you owed someone $9, right? And then plus 2, you paid them back 2. Have you paid them back yet, everything you owe them?
No.
No, so you're still negative. You still owe them more money. How much more money do you owe them?
None that I don't know it, I'm just completely tired right now.
You're not sure?
Yeah.
You want to help them out?
At the
About
moment, my mind's not working.
not working yet? It's a little early. How about Dylan?
Negative 7.
Yeah, it's still negative 7. Right? Negative 9 plus 2, negative 7. Okay, are we good?
No.
No? I'm going to make my number line. Since I don't have a lot of space, I'm going to number it by 2s. So I'm going to go like negative 8, negative 6, negative 4. And that's enough numbers. You don't always have to have 0 on it.
Mistake, can they just do for graphing, like put a 0 in the middle, put like a positive 7 on the right and a negative 7 on the left?
Yeah, they could do it that way too. You could put like 0 in the middle and negative 7, positive 7.
Yeah.
Yep.
As long as you have your positives to the left of 0 and your,
To the right.
your negatives to the left of 0 and your positives to the right, that's fine.
All right, so what kind of circle am I going to put on this one? Savannah? Closed. And where am I going to put it?
Negative 7.
Right, yeah, so negative 7, it's exactly right in between negative 6 and negative 8. Negative 7. And now, which way am I going to shade? Left or to the right? How about, right?
To the right.
Yeah, to the right. How do you know that?
Because it's pointing, like, that way.
Right, it's pointing to the right, and it's set up the way that it should be. Yep, good job. Letter, symbol, number. All right, so I'm just going to shade to the right. Any questions on that one? All right, so I'm going to have Mr. Roy take a look at a couple others with you, some that have decimals, and then we'll finish up, I think, with a word problem.
Okay, guys. So yeah, like Mr. Hager said, all the stuff we do today will just be adding and subtracting to solve. And tomorrow we'll do multiplication and division. And then next week, we'll probably get into like some two-step stuff, like 2x plus 4 is greater than or equal to 8. But we won't get to that stuff this week. It's kind of like how we did equations. Like we started with the basic ones first, then we get to the ones with more steps later on. All right? Jake, in this inequality, what letter do I want to get by itself?
Why?
I want to get y by itself, right? So the cool thing about this is there's nothing well, the easy thing about this, I should say, is there's nothing attached to it. It's not 2y, it's not 4y, it's not negative 6y, it's just, it has one thing with it, all right? So now we have a letter with some numbers. So this is what I think some people have a hard time with this. This is when you have a letter and then numbers, that's when you want to move stuff around. Like yesterday, we had you guys chat, like we said, is 3a solution. And we gave you something like this. We gave you something like that. We did that yesterday. That's when you're going to plug in 3 for x. So it'd be like this. Then we just do 3 times 3, 9, plus 5. Right? So because we can do that because we have all numbers here. If we have something, everything we have here is numbers. So we can just do the math, do the arithmetic and solve it. We're not going to go like minus 9 on both sides. We don't need to do that. We only do that when we have letters with numbers. All right? So like this one, we have letters with numbers, so we got to move stuff around. In this case, like Jake told me, I want to get y alone, right? And y has nothing attached to it, so there's only going to be one step. All right? Catherine, what's that one step going to be? I want to get y by itself, right? What's on the side of the inequality sign with y? If I look on this side, I want to box it out. If I look on that side, you have the y, right? What number is on that side of y? 8, right? What kind of an 8 is it? Positive. So what am I going to do? Subtract 8. Yeah. Again, there's nothing with it, right? There's nothing with the y. But again, there's nothing attached to y, but y is not isolated yet. What I mean by isolated is it's by itself. Nothing else is around it. No other letters are on that side of the sign with it. All right? So minus 8, whatever I do on one side, I have to do on the other side. We did this so it can cancel out. Whatever I don't use, I'm just going to bring down. I didn't do anything with the y, I didn't have to. I'm going to bring it down. I did nothing with my inequality sign. I'm just going to bring it down. Now, if I ignore the signs, if I ignore the signs, what's bigger, 8 or 5? 8, right? If I'm ignoring the signs. What sign is with 8? That means 8 is bigger than 5. 8 is negative. I take that sign. Now I just read it from the bigger number to the smaller number. All right? I already have my negative sign, so I'll read it from the bigger to the smaller. Because 5 minus 8, people have a hard time with because, again, it's a smaller number minus a bigger number. That makes it tough. But if I take the sign of the bigger number, put the minus here, I can do it from the bigger to the smaller. I can do 8 minus 5, which is what, Jake? 8 minus 5. You can do that one.
So negative 3.
Yeah, it'll be 8 minus 5 is 3. We already have the negative written there. There you go. That's what I'm saying. And again, you can just punch this in on your calculator. Hit the negative button. 8 plus 5. Or 5, not the negative button, but minus 5 minus 8. All right? You never want to do it on the calculator. You never want to do, let's see if I do 5 negative 8. It'll probably give me an error. See, error syntax. If I do, if I do 5 minus 8, I'll be good. All right. So whenever you have that minus, all right, when you have a minus in between two numbers like this, you don't want to put negative. You actually want to put minus, or it won't work on the calculator. Some people may already know that. I just wanted to show you guys. All right. So now we're gonna graph it, right? Well, like I was saying before, guys, you don't have to write every single number. What you can do is just put a 0, maybe skip a space, put 3, 0, skip a space, put -3. That's fine too. As long as your negative numbers out of the left, your positive numbers out of the right. All right? So Yusuf, what am I going to put here? How am I going to graph this?
So graph it's open and close circle, right?
What am I going to have? Open or closed?
Oh, as a line under some closed.
Closed where?
At negative.
Close at -3. What direction?
To the left.
To the left. There it is. That's it. Done. Again, that's all we're doing. Like I said, next week we'll get into stuff where you're gonna have to do 2 steps. You'll have to get it isolated and then multiply or divide, depending on what's there. All right. People okay with that one? All right. So this one. Couple things different here. Couple things different here. Obviously, number one, I have a decimal, right? I have a decimal in this one that I didn't have in this one. Why else is this one different from that one? Ellie?
Because it's supposed to be a letter and a number, but it's a number and then.
Yeah. All right. So it's in the wrong format.
Yeah.
So what do I have to do?
Flip it.
Anybody know what I have to do? Yusuf?
So let's put the M first, right?
All right. So I'm gonna flip. I'll put M first. Okay.
And then like change the symbol, right? And or should we put something else?
Was there anything else? Was there anything else with the M?
All minus the same, right?
No. On this side.
Oh, plus
Yeah, plus 1.4. Again, the signs are fine here because 1.4. Again, how do we know what sign belongs to what letter or number? Where is it located? How do I know what sign belongs with what number or letter? Jonathan?
it's to the left.
To the left, right? There's no sign with 1.4, so I know it's positive. And there's a positive to the left of them. Just be careful. If this was a negative 1.4, it would be M minus 1.4. But again, it's not like that, but just pay attention. You have to flip it, just pay attention to where your signs are. Alright? So there it is. Now, what in my original, right, before I flip it, what is the sign pointing towards? The -8 or the M plus 1.4? Joe, what direction is it pointing in? Towards the -8 or towards the M plus 1.4? The -8, right? So I want to make sure when I rewrite it, I want to make sure that it's still pointing towards the -8, right? That arrow is going to kind of help you make sure that you keep it when you flip it to see what it's pointing towards in the original. Then my last thing would be -8. So that's how we flipped it around. We flipped it. We're able to get the number. We're able to get the letter first. Then we have my sign. And then we have my number at the end. So again, same thing. It's going to be a one step, right? Alex, what letter do we want to get by itself? The M, right? Good. Get the M by itself. Nathan, how do I do that?
Subtract 1.4.
Subtract 1.4 by both sides. Minus 1.4. Minus 1.4. Now my answer here on this side. I don't care so much about the number. I care about the sign. What's the sign going to be? Positive or negative? It's going to be negative, right? Like Melanie said, it's going to be negative, right? 2 negatives, keep a negative. Two negatives, keep a negative, right? When would that become a positive? What operations would I need to be doing to make it positive, Yusuf? Multiplication or division, right? We're not doing that. That's when some people get screwed up. Let's go back to... I don't want that one. I don't like that one. Like the big one better. So we got what? -8, right? -8. Remember, in between, you want to hit the minus button, not the negative button. They're doing two numbers have a minus sign in between. You actually want to hit the minus sign, not the negative sign. I showed you guys that before. It comes out as an error. 1.4, right? -9.4. So I'm going to write it up here. Haley, what does that say? Good. Just want to make sure that we were all on the same page with that. Again, when you do your graph, you don't have to do, again, you don't have to do, you don't have to put decimals, right? Like I did before, what I would do is I would just put a 0, maybe skip a space, put -9.4. I could, actually, I don't want to do it like that. Let's do it like this. Let's go, I'm going to go, let's go -3, -6, -9, -12, 3, 6, 9, 12. So -9.4. Where would that be? Ellie?
In between -9 and 6.
Would it be to the left of 9 or right of 9?
Left of 9.
Yeah, because again.
To be in between -12 and 9.
Yeah, I wouldn't put it like, because again, we're going by threes here, so I wouldn't put it like right in between. If I put it right in between, that's going to be kind of like 11 almost, or 10.7 or whatever. I'd put it closer to 9, because the way that it's numbered.
Yeah.
I mean, if it was numbered by ones, like I had -9, then I had -10, something like that. I'll draw half a graph. If I had -10, -9, where would I put it in that case? If I was going by ones, where would I put my dot? If I was graphing my ones, Nicole? About halfway. What's halfway? What number? 0.5, right? We're almost halfway because we're 0.4. So I go almost halfway. But here, I'm going by threes, right? So I'm going to be a little bit closer to 9. Gigi, what type of circle am I going to put? Open, right? I'm going to open, close to 9. Right there. Bethany, what direction is my line going to go, my arrow? To the right, good. Draw my line. There I am. So there will be a couple on the test on Friday where there are decimals, right? So this one kind of made it a little bit more difficult than what we've done because number one, it had decimals, which some people are fine with, some people are not, and then also we had to flip it. All right, so two things going on that we hadn't really seen yet. All right. So you want to do this word problem?
Sure.
You guys have it written on there, right?
Yes, sir.
Okay.
Right, so the last one, let's see. It says that a circuit, like in your house, says overloads at 1,800 watts of electricity. So you plug in a microwave that uses 1,100 watts. It says write and solve an inequality that represents how many watts you can still add to the circuit without overloading it. All right, so what they're looking for, I'm sure we could figure it out, but what they want to see is an inequality.
Again, you're not solving anything, you're just setting it up.
So what do we know about the total watts on this circuit? If we don't want to overload it, how many watts are we allowed to use on the circuit? Yeah. Well, just before we even plug anything in.
Let's do the whole thing.
What's the circuit rated for? We got to use what?
1799.
Okay. What about 1799.9?
Yeah.
So how could we say that? we got to use, I'm looking for an inequality. Alex? Yeah?
Less than or equal to 1800.
Close. What would happen if we equal 1800? Then it explodes, right?
Yeah.
So we can't equal 1800, we have to be less than. All right? So just to kind of write down what we're thinking. Okay? So what we use, or what I'm going to say what we plug in, that probably makes more sense. What we plug in has to be less than 1800. So now let's look at what we've plugged in. What have we plugged in so far? How much?
1100.
Yep, 1100, 1100. So we've plugged in 1100. Now, how would I represent adding more to 1100? What operation? Because I can still do more than 1100. So how would we represent doing more to 1100? What operation? Yusuf?
I said addition.
Addition, yeah. So the question is, how much more can we add? Let's pretend I know some people already figured it out, but if we didn't know, how could we represent how much more we could still add to the circuit if it's something unknown right now? Yeah? Sure, X. So 1100 plus whatever else we add, whether you plug in a coffee maker, whatever else you plug in, it's got to be less than 1800. So we've written an inequality that represents how many watts we can add. Now we need to solve. How would I solve that inequality to figure out what X is? Donovan?
Subtract 1100.
So subtract 1100 from both sides. And I get that X, which is whatever else I plug in besides the microwave, it has to be less than 700 watts. So I'm just going to label it watts. So that means you can plug in however many more things you want, as long as it doesn't go over 700. So any questions on that? Okay, again, the point there, not so much figuring out like what the watts are. I think everybody knew it was 700, but coming up with an inequality. Okay, that's what we want you to come up with. So, in addition to the microwave, okay, on this circuit, we're going to plug in some other appliances, and I want you to tell me whether we can plug it in without overloading, or if we plug it in, we will end up overloading. So, clock radio. Could we plug the clock in with the microwave, and let's say the microwave is on at the same time? Yeah. So, the answer here is yes, you could plug that in. Could you plug in the microwave and the blender and have them running at the same time? Not the clock too, just the microwave and the blender.
Yeah.
Yep, you could do that. Could you plug in a microwave and a hot plate and have them both on at the same time?
No.
No.
I mean, you could, but it wouldn't.
Yeah, not without overloading it. It would shut off if you have a circuit breaker. How about a toaster?
Sorry, Chief. No, can do.
Nope, can't do it. All right, couldn't do it. Anyone ever see what's the movie with Tom Hanks where they go to the moon? Apollo
13.
13? I was thinking 11, 13. Yeah, 13. There's a part where they're coming back, right?
Yeah.
And they had some of the stuff on the ship broke, it malfunctioned, it burned out. So they had to decide they only had so many watts, and they had to turn on just barely what they needed without overloading the ship. Like they could turn on like I think they had to shut off the heat, so it got really cold. They had to shut off like the guidance system, so they had to fly the ship manually. They could only turn on like the bare minimum stuff they needed, like air, like life support, keep the air going, because they didn't have enough watts left to power the ship because something went wrong. But that's the idea here. There's only so many watts, so you have to decide what can you turn on, what do you have to turn off to make sure you can run the circuit. Yeah.
did that once in my house. I had my cousin over, and we turned on the stove and the oven and the microwave and everything electric at once, like all the lights and everything. You just hear,
Yeah.
and we had to go to the fuse box because everything blew out and everything was all broken and stuff, and we had to replace the fuse. My dad was mad at me.
Yeah, if you have fuses, if you've got fuses and they burn out, they're all done. You got to replace them. But if you got a circuit breaker, it just trips. You just push it back. And then usually that can happen like in the summer if you've got like a couple of air conditioners. Okay.
My house is right, wired for 6 different types.
Yep.
This one time, I had an extension cord plugged in, and the little cap at the end of the extension cord pops off,
Yep.
and it was still plugged in. I had the TV and the fan on in the living room. And of course, I go, oh, what would happen if I and I touched it, and it shocked me, and the whole living room went out.
Yeah.
Obviously that
I
happens.
just said, oh,
Obviously that
this
happens.
extension cord that's plugged in, the cap fell off, and I touched it, and I just,
Yes.
I love the whole
The other thing you got to be careful of too, if you know a little bit about electrical stuff, is if you have a really long cord, that makes a difference than a short cord. Like if I had a 50-foot cord versus a 2-foot cord, I can't run as powerful stuff on a 50-foot cord because it's so long, right? It makes a difference. So you got to be careful, especially if you plug in like a 200-foot extension cord. You got to plug in a really, really, really thick one if it's that long.
That would explain why I'm always blowing fuses. We do Christmas lights, like
Yep.
crazy Christmas
Yep.
lights.
So if you got really long extension cords, that can cause your circuit to overload as well. Yeah. All right. So we've got a little bit of time left. So keep your notes out. We've got some extra practice we're gonna have you guys try. Homework tonight just gonna be like last night. Worksheet. Reference sheet. We're gonna get it on Google Classroom by tonight, so that way you'll have time to print it tomorrow in school if necessary.
Or tonight at your house, if you want to start tonight.
Or you can print it tonight at your house. No review day this week because it was a short week. If we have a short week, we usually can't fit a review day in, so no review day. And now we've got some extra examples we're going to have you guys look at.